Hello and welcome to this video out of my series BGP for Networks Who Peer. I am Wolfgang Tremmel from the DE-CIX Academy. If you are interested in more videos, have a look at our YouTube channel or check the DE-CIX website at decix.net/academy. This video series explains BGP, the Border Gateway Protocol, for network operators or for everybody who wants to know how large-scale routing in the internet works. Today I'm going to talk about BGP communities. But let's get started with a quick summary of the first videos. We learned about BGP announcing prefixes. Prefixes are announced from one network, called in BGP an autonomous system, to its neighboring networks, also called autonomous systems. All these autonomous systems are identified with an AS number or autonomous system number. And the prefixes, they carry attributes like the BGP pass, a next hop, and so on. Attributes of BGP prefixes. There are several ways to classify these attributes. There are mandatory attributes. These are attributes which have to be there. For example, the AS pass is a mandatory attribute. That means every BGP announcement of a prefix always contains an AS pass. There are also optional attributes. Well, they are optional. They do not have to be there. For example, MED, that's the multi-exit discriminator. It's an optional attribute. It doesn't have to be there. Another way of classifying these attributes are if they are transitive or not transitive. Transitive attributes, they are attached to a BGP prefix announcement and they're kept on the prefix and forwarded via eBGP until they were explicitly taken off. Non-transitive attributes, they are added by one BGP speaker. They are announced to a neighbor, but they are not transported forward to the next autonomous system. Some example for BGP attributes. For example, the AS pass. That's a mandatory attribute. The origin type is also mandatory. It's added by the originator and it should never be changed but simply forwarded. The next hop is a mandatory attribute. MED, as already mentioned, it's optional or non-transitive. So it's announced to the next AS, but then it's taken off and has to be explicitly added again if the AS wants to re-announce that prefix. Local preference, that's mandatory for iBGP, but it is not sent via eBGP. Also a BGP attribute. The IANA keeps track of all these attributes and attribute codes and has listed them on their website. Currently, there are more than 40 attributes registered. Now I would like to introduce BGP communities. BGP communities are a transitive, optional BGP attribute. Transitive means once attached, it stays. Optional, it doesn't have to be there. You can think of BGP communities like stickers on a suitcase. The suitcase is the BGP prefix announcement and the communities are stickers you put onto this suitcase. Once they're on unless somebody peels them off. So BGP communities like stickers on the suitcase of a BGP announcement. They were first defined in 1996 and the formal definition of a BGP community is a community is a group of destinations which share some common property. Introduced in RFC 1997 and the original BGP communities are expressed by a simple 32-bit number. In reality, this 32-bit number is split into two 16-bit numbers. The high 16-bit are an AS number defining the low 16-bit. For example, 6695:1000. And the notation are 2 decimal numbers separated by a colon. And you might ask how many BGP communities you can attach. Well, as many as you want, within reason. Keep in mind the BGP maximum message size is 4 kilobytes. So everything which fits in this 4 kilobytes you can do. What are these communities useful for? You can add information to BGP prefixes. Like, for example, this BGP prefix was received in Europe, or was received in Frankfurt, or was received at DE-CIX. So you define a BGP community, define a meaning for that. Keep in mind a community is just a 32-bit number, and you attach that 32-bit number to a BGP prefix. Additionally, you can also add other information, like it was received from your upstream provider, it was received via peering, or from a customer. So all this information you can define, put it in a table, publish it, and then use the community numbers to add them to a BGP prefix. For example, you can encode geographic information. Even with just a 16-bit number like it is here shown, you can attach from which country a prefix was received. For example, the first digit you set to 1, that means there is geographical information following. You have now 4 more digits available. The second digit, you can encode a continent. You can easily encode a continent within 1 digit. There are not that many continents. And the remaining 3 digits, you can use a country code. There is a 3-digit numerical ISO country code. Look it up on the web, and you can encode a country in the remaining 3 digits. So here you can encode where the prefix was received. Also, or additionally, you can encode logical information. Like you set the first digit to a 2, that means logical information follows. Then you can define the next digit like it was received from an upstream provider, from a peer, from an internet exchange, from which internet exchange, and you have 3 digits more to add other information like a customer ID or a postcode or whatever you want. You can also use communities for action, like you can define what should happen with this prefix if a certain community is been attached, like announce this prefix to DE-CIX or announce this prefix to your upstream provider. That's completely up to you to define that. There are also so-called well-known communities. Well-known communities are predefined communities, predefined by within an RFC. For example, there is the no export community. If this is attached to a prefix, it means do not re-announce that prefix to any external BGP neighbor. There is no advertise. That means do not announce this prefix to anyone, even not to IBGP. Graceful shutdown. A prefix with this community attached, its local preference is set to 0 so that this BGP announcement is not used by routing. Black hole. That means sync all traffic to the prefix targeted with that community. These well-known communities are predefined, and most BGP implementations honor them, and you simply have to set them. You do not have to configure your router to use them. They are already implemented in your BGP implementation. Now, I said that the BGP community is 32 bits in length, and the first half is an AS number. Do you have a 32-bit long AS number? So there is no luck with the original BGP communities. Original communities are two 16-bit numbers. You cannot express a 32-bit AS number in the higher part. There is no way to encode that. So extended communities were defined. Extended communities brought a lot of new features. In total, an extended community is 64 bits long. It introduces a type field, and it introduces flags for telling it's a private or a public community, or it's transitive or non-transitive. So this is how extended communities look like. We have first the two flags. The first flag means it's IANA assigned or it's private. The second flag means it's transitive or it's not transitive. If it's not transitive, it's removed before forwarding to the next AS. Then we have the type fields. For a list of possible types, see the RFC. And then we have 48 bits in total for a value. We can express a 32-bit AS and a 16-bit value, or we can express a 16-bit AS and a 32-bit value. What we cannot do is, what we would like to, having a 32-bit AS and a 32-bit value. That's not possible with extended BGP communities. The notation of extended BGP communities is similar to the original ones. You have first the type. Here we have a route target community. Then we have an AS number, in this case a 32-bit AS number, and then we have a 16-bit value. The disadvantage, clearly, only 48 bits in total. You can express only one 32-bit value, so you cannot express two 32-bit values. And the type fields like RT, route target, RO, route originator, that was quite confusing for many operators. So where they are really needed, for example, to add information to EVPN BGP announcements. That's where they are needed and that's where they are used. Conclusion here, for peering and routing, we need something different. And it took the IETF quite a while to realize that. And finally, there was something useful defined, and that's our large BGP communities. Large BGP communities are very simple. It's three 32-bit values. And the first 32-bit number is the so-called global administrator, and that's an AS number in 32-bit notation, which defines the rest, which defines the other two fields. And you can also, if you define these fields, you can publish the meaning. And then we have two fields also called local data. It can be seen as just two 32-bit numbers or like function plus parameter. The notation is similar to the original communities, so three 32-bit numbers separated by colons. The whole thing is defined in two RFCs. One defines the attribute and one gives use examples. And there is even a dedicated website for that called largebgpcommunities.net. Recommendation. I rarely give recommendations in these videos, but this is one here for you. If you are starting fresh with BGP communities, simply only use large communities. Forget traditional ones, forget extended communities. If you are starting fresh with BGP communities in your network, just use large communities. You can do everything with them. They are clearly defined, they are well implemented, and the handling is much easier with a number space of 3 times 32-bit. Action communities, also very simple. Use your AS number as a global administrator and, for example, to express announce this prefix to upstream providers only in Europe, or not in North America. Simply define what you want and then implement it. You may also allow your customers to send you some actions. Have these all defined before you start implementing, because you know the best ideas come last. So first write it down what you want and then implement it on your routers. The encoding, it's completely up to you. There are enough possibilities. And that's it for today. Thank you for listening. I'm Wolfgang Tremmel from the DE-CIX Academy. Thank you and bye-bye.